This video is for algorithms for the division of whole numbers. So we've talked about addition, subtraction, multiplication, algorithms. Division has an algorithm also, and it's stated in our book. The long division algorithm is the most complicated procedure in elementary school mathematics curriculum. And so you do end up spending a lot of time helping students through this, and they are memorizing many of the time, so that's why it becomes a difficult process, and there's multiple steps, so that becomes a process. And if students don't know their multiplications, right, then that also becomes a process because that is something they got to be very proficient with to do the long division. So let's try an example and remind you of what that looks like when we do, so let's do 461 divided by 3. So let's do a long division first, the algorithm, just to remind us. So that number goes in there, and then so the question that gets asked is, right, in this situation here, the question that gets asked is, how many does 3 go into 4? And the answer is yes, one time. And then you bring a 3, 1 times 3. And so now when you're really thinking about this, it doesn't make that much sense because you're really asking 461 divided by 3, and then you go, how many times does 3 go into 4? Right, even though that 4 represents 400, it's kind of confusing. 1 times 3 is 3, and then subtract, right, for some reason. You bring down that one. Is 3 go into 16? Yes, 5 times. And so 3 times 5 is 15. And so what you end up with is 1. Bring the 1 down again. 3 go into 11, and the answer is yes. How many times? 3. 3 times, and then you go with 3 times 3 is 9, 2, and so your answer is 461 divided by 3 is 153 remainder 2. And so as you're starting to do this, these numbers that you keep dividing back into are not part of the original number. And so students get confused because they're not sure where that comes from. And so really the picture that you want to represent is with base blocks. So if we think about this, let's put this together here and think about this as a sharing division problem. Here's 400, right? There is, let's go with colors here. There are 6 tens. And what we're trying to do is break this into, if we think of a sharing division, we want to break this into 3 groups. Let's go with black here, and you end up with one of this here. And so what ends up happening is the standard algorithm for division is really asking you to break this up into 3 groups. So if we were going to break this up into 3 groups, there's 1 group, 2 groups, 3 groups, and start breaking it up, you will then ask yourself, how many hundreds can I share? Well, what's going to happen is there would be 100 here, 100 here. There's my 3 groups, right? And so then that's gone, gone, gone. I'm still left with 1 group of 100, but I can't break that up. So what happens is that this one right here, this 100, then becomes 10 of these, right? So that disappears, and I end up with 10 tens. That 100 comes to 10 tens. That's 3, 4, 5. Becomes into 10 tens. So you end up regrouping. And now you're saying, how many tens do I have? I have 16 tens, right? There's my 16. And then how many can I share that out? That means that each one would get 5. And so out of that 16 left over, each of them gets 5. And so I'm literally distributing or sharing those tens out. And then, so that means I've put in 15. So that's all of them. Those 2, 4, 6, 8, 10, 12, 14, 15. So you can see there's still 1 left. So then what happens is this one becomes 10. That becomes 10 ones. There's 6, 7, 8, 9, 10. So what you're left with now here is you have 16 tens. Here you have 11 ones. And so that's what now gets distributed out there, and then you can see each of them gets 3. Each gets 3. There's my 9, and then there's 2 left over, remainder 2. So your answer then is 153, remainder 2. And so that's what the division algorithm is. So you're going to have to practice doing the standard division algorithm. I just want to make sure you understand where that is coming from. How long division in that algorithm really is coming from a sharing division model where you have a total and start to break it into that many groups. Lastly, there's another method that appears. It's called Scaffold Method. It's the way I want you to be aware of, because it's not you don't have to kind of memorize all these steps. All you have to kind of do is ask yourselves, how many times does the original number go into the big number? So how many times does 31 go into 5,739? Because that's what a division question's asking. And so we don't know the answer, so what you do is you just start with a guess. It's like a guess and test. How many times does 31 go into 5739? 100? Let's see, does it? Yeah, it does. So 100 times 31, times 31 is 3100. What's left over? And you have a leftover amount. And then you ask yourself a question again. How many times does 31 go into this number? Well, let's go 50 times. It does. You subtract, you have a leftover. How many times does 31 go into 900 and it goes into 1089? About 30 times, and then you multiply, get the answer. And so this is a guess and test method. Okay, some of you really like guess and test. And so division this way, which I kind of like because I don't have to memorize all these steps. I can just actually do the subtraction. So let's finish this division algorithm here using this right here. So it's 4238, and then you ask yourself, how many times does 56 go into this? I don't know, so let's take a guess. Let's go with, I know 10. Just show an example. I know it goes into it 10 times. So then I'm going to put a 560 here. Okay. And so I know, like we were saying, it goes in 10 times. 56 goes into this at least 10 times. So you're going to do 56 times 10 to figure out. We know that's 560. And so when we do that, we then find out what's left over after it goes into it 10 times. You get 8, 7, borrow or regroup. I don't want to use the borrow, so it's 12. This becomes, becomes 11 minus 5 is 6, and this becomes a 3. So I know it goes into it at least 10 times. Now I can ask myself a question again. How many times does 56 go into this number here? I'm going to be a little bit more brave and say, let's try 50 times. So if I do 50 times 56, this gives me 2,500 plus 300. So that's 2,800. It goes into it. 50 times 56, 28. So what is left over? 8, 7, 16 minus 8 is 8. Now I can ask myself again this question, how many times does this go into it? I know for sure 10 times. So I'm going to play with 10 again, since I know that's 560. And so then you end up with 560. There's your 8. What's left over? 1, 3. And so then now we have 318. And so let's play with 3 times, 4 times, 5 times. I think it goes into at least 5 times. Let's see. So 5 times 56, that'd be 250 plus 30. So there's your 280. 8, borrow, that's a 3. And that was a 2. So now I'm left with 38. 20, 30, yep, 38. And so that would be it. I would be done with this problem. 4238 divided by 56 is going to be 50, 60, 70, 75, remainder 38. 75, remainder 38. We can check that real quick. Let's do 75 times 30, times 56. Let's do that real quick. 78 times 56. trying to get, we'll do that, and then remainder 38. So 5 times 6 is 30, 3, 42, so that's 45, 0, 5 times 5 is 25, 2, 5 times, oh, I'm way off. Let's do this again real quick. 6 times is 30, carry the 3, oh, I think I was good. 450, carry a 0. 5 times 5 is 25, put the 2, 5 times 7 is 35, plus 2 is 37, so you end up with 0, 0, 1, 8, 38. I'm off, carry 1. Oh, I'm so off. Where are we? Oh, 12, 10, 12, 4,200. There it is. So you have 4,200 plus the remainder 38 equals 4238. So we did that right. That's a scaffold method, and you're going to have to practice that. I just guarantee you. Okay. Now, I'm going